Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.4, Problem 8. This is Section 11.4, problem number 8. The problem says, find the equation of the line that is tangent to the function f of x equals x squared minus 4x plus 5 at the point where x equals 1. So there's a little hint that comes with it. It says hint, when a line is tangent to a function, it touches the function at just one point, and the tangent line has the same slope as the graph of the function at that one point. And then there's a diagram to help you visualize that. So we have some function. This isn't the one exactly from the problem. This is a general function. And if there's a tangent line, it'll touch at that one point. And at that one point, whatever the graph of the function is, the graph here and the graph of the straight line are the same. And then the hint goes on to say, since the tangent line is a straight line, you can use the formula y minus y1 equals m times x minus x1. This is the formula for the equation of a straight line to find the equation of the tangent line. So now when we plug into this y minus y1 equals m times x minus x1 formula, it has three parts that we need to put in a number value. So let me write it underneath here in a different color. Y minus y1 equals m times x minus x1. We have to find a number value for y1, a number value for m, and a number value for x1. The rest of that answer just stays. And we can simplify it, we can solve it for y, but the rest stays. The parentheses, the x, the y, the equals. So right away I know the value for x1. The question tells me it's 1, positive 1. So I can do y minus y1 equals m times x minus 1. Because the question says x is 1. So I still have to find the m, I still have to find the y1. Now in terms of the y1, they don't tell me y1 in the question, but because I'm given the function, for any x, I can find the y. So right underneath, I think I have enough room. Let me put in a 1 and see what I get as an answer. That answer will be the y value at that point. So again, in a different color, f of 1, because the question says to use 1 for x, equals x squared is 1 squared, minus 4 times x is 4 times 1, plus 5. So I have a positive 1 from 1 to the second and a positive 5. So positive 1, positive 5 is going to be 6. And then 4 times 1 is 4. It's negative. So positive 6, negative 4. When I put in a 1 for x, the y that comes out is 2. So I can put that answer of 2 in for my y1. So y minus 2 now equals m times x minus 1. So the only thing I need to find is the m, which is the slope. Now, what finds slope? The derivative. So we've done derivatives. So what this problem amounts to now is we have to find the derivative of the function that's given in the problem, f of x equals x squared minus 4x plus 5, and use that derivative to find the slope at this point when x is 1, because that's what the question asks us to do. So let me write the formula for the derivative and start putting in values. So the formula for the derivative, f prime of x, that's the notation for derivative, equals the limit as h approaches 0 of that formula. And like I've done in previous problems, let me write it in the different colors that I usually use. So f of x plus h, I typically put that in blue. Then I have minus. Then I'm going to have f of x. And in the denominator, just an h. And I'll close up my brackets. So that's the formula for derivative, f prime. So if I can calculate this, it'll tell me the slope everywhere. And I'm going to want to know the slope where x is 1. So in blue, off to the side here, let me calculate what f of x plus h is. And then I'll start plugging stuff in, and I'll take the limit and everything. So let me start with f of x equals, the question tells me it is x squared minus 4x plus 5. So now when I use x plus h as an input, I'll have f of x plus h equals x squared now is x plus h squared. So it's x plus h in parentheses to the second power. Then the minus 4x becomes minus 4 times in parentheses x plus h. And then the 5 at the end just stays at the end. So that is the answer, but we need to simplify it, cancel stuff, group like terms, and all that stuff. So f of x plus h equals, now again, when you have a quantity in parentheses raised to the second power, it's that set of parentheses times itself, the same parentheses again. That's second power. So you have to do a FOIL for that, x plus h times x plus h again. Now the next piece, negative 4 times x plus h. I'll have negative 4 times x is minus 4x. Negative 4 times h is negative 4h. And again, you have a 5 on the end. So I'm going to have to do some of the work is to do out this FOIL. So f of x plus h equals, so x times x is x to the second. Then I'm going to have x times h is hx. So that takes care of the x. Now this h times each piece in the other parentheses. H times x is hx again. Then I'm going to have h times h is h second power. And then I can bring the rest of the problem down. Minus 4x minus 4h plus 5. And I can just combine the hx and the hx here. And finally I have f of x plus h equals x squared plus 2hx plus h squared minus 4x minus 4h plus 5. So for the formula for the derivative, or f prime, the blue portion, f of x plus h, is equal to x squared plus 2hx plus h squared minus 4x minus 4h plus 5. And the other parts are easier. So now let's start working that down. So I'll have f prime of x equals the limit as h approaches 0 of, and then in blue, for f of x plus h, I have x squared plus 2hx plus h squared minus 4x minus 4h plus 5. And I have minus, this minus here, f of x, which is written in red. And now f of x is given in the question. It is x squared minus 4x plus 5. I'll just make a little more room. Push that bracket back a tiny bit. And again, as you subtract off the f of x that I've written in red, to do it right, you really need to use parentheses so that you don't lose a sign. And then in the denominator, I just have h. So now I've filled out the formula for f prime of x. I have to take that limit as h approaches 0. And in order to let h run down to 0, I need to get the h out of the denominator. So I'm going to do, I'll go all to blue now, f prime of x equals the limit as h approaches 0 of, and now as I fill this in, any part in the numerator that does not have an h in it, like this x squared, should cancel. There should be a same identical piece with the opposite sign. So here's an x squared, here's an x squared. The first x squared is positive. The second one, because it's being subtracted here, is negative. So positive x squared, negative x squared. Cancel. The next piece, 2hx, it has an h, so it can stay. And again, there's no other 2hx. So this will come down into the numerator of the next line I'm working on. 2hx, so I've accounted for that. I'll cross it off now. H squared is next. Again, there's no other h squared. And basically, my rule of thumb is if it has an h in it, it's going to be able to stay. So I'll bring that down. And again, I've accounted for it, so it's done. I'll cross it off. Now, in the numerator, there's a negative 4x. It has no h, so there should be a matching 4x somewhere that's positive. And if I look in the parentheses, here's my 4x. There's a minus in front of it, but if you go far enough to the left, there's another minus that'll cancel. This is really a plus 4x. This one is a positive 4x. Oh, negative 4x, rather. And this is a positive 4x. So I have two 4x's. One's positive, one's negative. They will cancel. The next piece, minus 4h. It has an h. It can stay. And again, as you look, there is no corresponding positive 4h. So I'll just bring it down to the next line where I'm working. Minus 4h. It's been accounted for. I'll cross it off. Here's a 5. Again, there's no h, so there should be a matching 5 that's negative. And sure enough, here it is on the end. Because of the negative in front of the parentheses, the last 5 on the far right that's printed in red is negative. The first 5 that's printed in blue is positive. They'll cancel. Positive 5, negative 5. So the whole numerator has been condensed down quite a bit. And again, in the denominator, I have an h. Close my brackets. So it doesn't look as bad as the previous line. Now again, my intention is to let the h run down to 0. I can't do that yet because I still have an h in the denominator. You can't have a 0 in the denominator. That's undefined. So my tops all have an h. I'm going to factor that out and use the factored out h to cancel the 1 in the denominator. So f prime of x equals the limit as h approaches 0 of, so what I'm going to have here is some parentheses with an h in front and then some stuff inside. Now the stuff inside the parentheses, this first piece, 2hx, when I take an h in front of the parentheses, it's going to leave me with a 2x. The h to the second power, when I take an h in front of the parentheses, it's going to give me an h to the first power, just plain old h. This minus 4h, when I take an h in front of the parentheses, is going to be minus 4. Again, pay attention to the sign, not just 4, minus 4. And now I have an h in the denominator. Now that h in the denominator can cancel with the h that I factored in front of the parentheses. So now what I want to do is do f prime of x equals the limit as h approaches 0 of 2x plus h minus 4. Now that I have no more h in the denominator, the remaining h, I can allow it to run down to 0 because that's the limit I want to take. So what I have is f prime of x equals 2x plus 0 minus 4. And the plus 0, what it really amounts to is f prime of x equals 2x plus minus 4. Again, pay attention to the sign. That's f prime. That's the derivative. F prime of x equals 2x plus 4 will tell me the slope at any value of x I want. Which value of x would I want to know the slope at when x is 1? Because that's what the question asked me to find. So again, going back to my graph of the tangent line, the x value in our problem has an x is 1. So I'm going to take my f prime of x that we did so much work to find and put in a 1 for x. So 2 times x is 2 times 1 minus 4. 2 times 1 is 2. 2 minus 4, negative 2. So when x is 1, the slope is negative 2. Now again, for different values of x, it'll have a different slope. But for the part that we have to find, the slope is minus 2. So now again, coming back to the left, if you remember so long ago, we started our y minus y1 equals m times x minus x1. The value of x1 we were able to put in right away because the question said x is 1. And without too much work, we found the value of y to be 2 because we put the x is 1 into the function that they gave us. If you put in the x, you find the y. But we had a lot of work to find the m, which is the slope. But now we have it. It's negative 2. So my final answer is y minus 2 equals negative 2 times x minus 1. Now, this solution can be simplified. You can put it in y equals mx plus b form if you like. But this is the equation of the line that is tangent to the function they gave us at the point where x equals 1.